A new danger stalks city streets. It moves silently, almost invisibly. It is the electric vehicle, or EV. Studies reveal a startling truth. EVs are involved in pedestrian accidents at a higher rate than their gasoline-powered counterparts. This unsettling trend, while seemingly counterintuitive, has experts searching for answers. Is it the technology itself, or are there other factors at play? The silence of EVs, often touted as a benefit, may be their Achilles heel. Pedestrians, accustomed to the auditory cues of combustion engines, are caught off guard by the stealthy approach of EVs. This is particularly problematic in urban environments where foot traffic is high and distractions abound. The lack of engine noise creates a sensory gap, increasing the risk of collisions. This issue extends beyond mere inconvenience. It represents a fundamental shift in how we perceive and interact with vehicles. As cities embrace cleaner transportation options, the safety of all road users must be paramount. Understanding why EVs pose a greater risk to pedestrians is the first step towards mitigating this danger. For decades, the roar of an engine has been a warning signal, alerting pedestrians to the presence of a vehicle. This auditory cue is deeply ingrained in our subconscious, triggering an instinctive response to look, listen, and stay clear. EVs, with their near-silent operation, disrupt this well-established safety mechanism. The lack of engine noise creates a false sense of security, leading pedestrians to misjudge the speed and proximity of approaching vehicles. This phenomenon is particularly pronounced at low speeds, where EVs are at their quietest. Studies have shown that EVs are significantly more likely to be involved in low-speed collisions with pedestrians, especially when turning or reversing. This suggests that the lack of engine noise makes it difficult for pedestrians to detect EVs in situations where visibility may be limited. Moreover, the quiet operation of EVs can have a masking effect, drowning out other auditory cues that pedestrians rely on. The sound of footsteps, bicycle bells, or even other vehicles can be obscured by the absence of engine noise, further increasing the risk of accidents. This is particularly problematic in urban environments where multiple sounds compete for attention. The rise of EVs coincides with a global push towards urbanization. Cities are becoming denser, with more people living, working, and moving within a confined space. This concentration of pedestrians and vehicles creates a complex and often chaotic environment. In this context, the silent threat of EVs becomes even more pronounced. Cities are not only densely populated but also highly stimulating environments. Pedestrians navigate a constant barrage of sensory input. Traffic lights, billboards, street performers, and the general hustle and bustle of urban life. This sensory overload can lead to distraction and inattention blindness, making pedestrians less aware of their surroundings. The combination of these factors, increased pedestrian density, sensory overload, and the silent operation of EVs, creates a perfect storm for accidents. Pedestrians already overwhelmed by their surroundings are less likely to notice a silent EV approaching, especially in situations where visibility is limited. This highlights the urgent need for safety measures that address the unique challenges posed by EVs in urban environments. Section 4. Behind the wheel of change. Who are the drivers of these silent machines? Data suggests that EV owners tend to be younger, more affluent, and more tech-savvy than the average driver. While this demographic is often associated with early adoption of new technologies, It also exhibits certain driving behaviors that might contribute to the problem. Studies indicate that younger drivers, particularly males, are more prone to risk-taking behaviors behind the wheel, such as speeding and aggressive driving. While EVs themselves are not inherently dangerous, their quiet operation might amplify the risks associated with such driving styles. The lack of engine noise might create a false sense of speed and distance, leading to misjudgments and collisions. Furthermore, the tech savviness of EV drivers, while generally positive, might also play a role. The advanced infotainment systems and driver assistance features in many EVs can be distracting, diverting attention away from the road. While such features are intended to enhance safety, their overuse or misuse can have the opposite effect, particularly in complex urban environments. Section 5. A collision of factors. The increased risk of pedestrian accidents involving EVs is not a result of any single factor, but rather a confluence of circumstances. The quiet operation of EVs, coupled with the sensory overload of urban environments and the driving behaviors of a particular demographic, creates a complex interplay that increases the likelihood of collisions. This phenomenon challenges our assumptions about vehicle safety. For decades, we have associated loud engines with danger and quiet vehicles with safety. However, the rise of EVs flips this script, forcing us to reconsider how we perceive and interact with vehicles in the 21st century. The lack of engine noise, once considered a virtue, is now a potential liability, particularly in urban areas where pedestrian safety is paramount. This is not to say that EVs are inherently unsafe. Rather, it highlights the need for a paradigm shift in how we design and regulate vehicles in the age of electrification. As cities embrace cleaner transportation options, safety measures must evolve to address the unique challenges posed by quiet vehicles in crowded urban environments. Section 6. Sensing the unseen. So, how do we address this silent danger? One solution lies in technology itself. Automakers are increasingly equipping EVs with acoustic vehicle alerting systems, or AVAS. These systems emit artificial sounds at low speeds, mimicking the noise of a traditional engine. The goal is to alert pedestrians and cyclists to the presence of an EV, restoring the auditory cues that we have come to rely on. However, the implementation of AVAS is not without its challenges. There is no standardized sound for EVs, leading to a cacophony of beeps, whirs, and hums that can be confusing and even annoying. Some argue that these artificial sounds are not loud enough or distinctive enough to be effective, particularly in noisy urban environments. Beyond AVAS, other technological solutions are being explored. Advanced driver assistance systems, or ADAS, such as pedestrian detection and automatic emergency braking, can help mitigate the risk of collisions. These systems use sensors and cameras to monitor the vehicle's surroundings, providing warnings or even taking control of the vehicle to avoid accidents. Section 7. Towards a safer future. The rise of EVs presents both an opportunity and a challenge. While they offer a cleaner and more sustainable mode of transportation, their silent operation poses a unique risk to pedestrians, particularly in urban environments. Addressing this challenge requires a multi-pronged approach that encompasses technological solutions, driver education, and urban planning. Automakers must continue to refine AVAS technology, developing standardized sounds that are effective and unobtrusive. Driver education programs should highlight the unique safety considerations of EVs, emphasizing the importance of cautious driving in pedestrian-heavy areas. Furthermore, urban planners should consider infrastructure changes, such as dedicated bike lanes and pedestrian-only zones, to create safer spaces for non-motorized road users. Ultimately, creating a safer future for all road users requires a collective effort. Automakers, policymakers, drivers, and pedestrians must work together to ensure that the transition to electric mobility does not come at the cost of safety. By acknowledging the silent danger posed by EVs and embracing innovative solutions, we can create a future where technology and safety go hand in hand.